this lecture, part 1 of lecture 4 today. Uh, I hope you are acquainted with vector identities. We'll go through these vector identities, particularly related to vector calculus. Uh, but just two identities which are related to vector algebra, which are useful. Those two identities we'll see first. I'll just uh, point out those identities. Then we'll come to identities related to vector calculus. The first identity is called as scalar triple product. In this, what happens is we take a vector product of two vectors, then we take a scalar product of those two vectors. As you know, the vector product is a vector, so resulting vector is taken as a scalar product with another vector. So A is one vector, B is another vector, C is another vector. We take vector product of B cross C, B and C, which is B cross C. Then we take the dot product of B cross C with A. Now in this, a property is that we can always interchange the dot and cross. So A dot B cross C is same as A cross B dot C, which is also same as C dot A cross B. As you know, A dot B is equal to B dot A. So this, since vector product in scalar product is commutative in nature, A dot B is equal to B dot A. Similarly, we can use C dot A cross B. A cross B is a vector, C is a vector. We have a dot product. Therefore, we can interchange that. That is same as A cross B dot C. Right. So A cross B dot C is same as C dot A cross B. Now C dot A cross B, we will now interchange the cross and dot product. If we interchange the cross and dot product, then we get B dot C cross A. So A dot B cross C is equal to A cross B dot C is equal to C dot A cross B is equal to B dot C cross A. I hope this is clear. Similarly, we have something called vector triple product, in which the product is all the products are cross products. There is no dot product involved. So we have three vectors A, B, C. We will take B cross C. The resultant of B cross C is cross multiplied with A. So A cross B cross C. Now this is the resultant is B into A dot C. So B is a vector, A dot C is a scalar, B into A dot C. You know, any vector can be multiplied by a scalar. So if I have a vector A, I can multiply A with X, X is a scalar. So XA or AX. Similarly, here it is B A dot C minus C A dot B. Now, if you can look at this, this is BAC. The chronology is BAC, then CAB. So this, to remember this, what will happen or how to expand A cross B cross C, we call this the back cab rule. BAC is back, CAB is cab, back cab rule, BAC minus CAB. So B A dot C minus C A dot B. So vector triple product is determined by back cab rule. These are the two products, two vector products, scalar product and triple product, scalar and vector triple product that we'll be using in vector calculus, identities of vector calculus. These are two important identities. So you can practice this, either you remember this or practice this. I hope you know this earlier in your undergraduate course. So let us come to the vector calculus identities. The first identity that comes is uh, gradient of phi plus theta. What is gradient of phi plus theta? As you know, gradient is actually nabla operator operating on phi plus theta. Right. Now nabla operator or del or nabla operator, that is a vector as well as a differential operator. Now, since it is a differential operator, you know d by dx of fx plus gx is equal to d by dx of fx plus d by dx of gx. So that differential and differentiation part is distributed. So we'll do that del of phi plus theta is equal to del of phi plus del of theta, or grad of phi plus theta is equal to grad of phi plus grad of theta. So this is a simple identity. It is easy to remember. You can always do this. Then we'll come to the next identity, which is the divergence of A plus B. So the next one is divergence of A plus B. Divergence of A plus B, again this is also a differential operator and vector operator. So since it is a differential operator, it will be distributive in nature. Therefore, it will be distributed over A and over B. So del dot A plus del dot B. Divergence of A plus B is divergence of A plus divergence of B. Next is curl of A plus B. Again, uh, delta is a differential operator. We'll again use the distribution law. So curl of A plus B is curl of A plus curl of B. Then the next identity is grad of phi theta. So gradient of phi theta. So what we have here is two variables, phi and theta, multiplication of two variables, and on that we are operating grad. Now you know d of uv is equal to u dv plus v du. So what will you do in the case of differentiation is, first you take one as constant, operate differentiate the other one, plus add it, take the other one as constant, differentiate in the first one. So similarly here we will do the same thing. So delta will operate on phi first, then theta will be constant, then plus delta will operate on theta. In that case phi will be constant. So this we can write as delta phi. Phi subscript means it is operating on phi. Theta subscript means it is operating on theta. When we take phi subscript, theta is a constant, so we'll take theta outside. So it will be grad of a theta into grad of phi, plus when we take theta subscript, it is operating on theta only. So phi is a constant. We'll take phi outside the operation. So it will be phi of grad theta. So grad of phi theta is equal to theta grad phi plus phi grad theta. So this is an operation which we use again the differential rule d of ub. Using that rule we find out this identity. Grad of theta phi or grad of phi theta is equal to theta of grad phi plus phi of grad theta. Next is when we take divergence of phi a. Now when we take divergence of phi a, uh, grad will del will operate on phi and del will operate on theta a. When del operates on phi, we say it is del phi dot phi a, plus when it is operating on a, we again say del a dot phi a. Now that will be equal to, in the first case, it will be operating on phi. Phi is a scalar. Therefore, we cannot take dot product of del with phi. So we'll take the grad of phi. Then we take the dot product with a. So a will be outside. So it will be a dot grad of phi. First term will be a dot grad phi. Second term will be phi, take common. So that will be a del dot a, or divergence of a into phi. So grad phi dot a dot grad phi is same as grad phi dot a. So grad phi dot a plus divergence of A into phi. Phi is a scalar, we are multiplying divergence of A with a scalar. A scalar multiplied by a scalar. Okay. Now that again will be equal to A dot grad phi plus phi grad dot uh, phi divergence of A. Now you can see on the left hand side we are taking divergence. We are taking divergence means left hand side should give us a scalar. So look at the right hand side. Right hand side we have two dot products. So they are giving us scalar. So left hand side and right hand side both are giving us scalar. So this way we can check that our identity is correct. Next is the del dot A cross B. What will be del dot A cross B? Let us find out this. Now when we find out del dot A cross B, again here del will operate on A, then del will operate on B. So this we can expand as del operating on A dot A cross B plus del operating on B dot A cross B. Uh, so that will be equal to B dot del cross A, because when operates on A, and that is we are taking a dot product. If I take del dot A, that will become a scalar. Scalar cannot be cross multiplied with a vector. Therefore, the first term will be del cross A. As you know, we can interchange dot and cross. So del cross A dot B. So that becomes that B dot del cross A, the first term. Second term is del cross B dot A, which is A dot del cross B. So finally we'll get B dot del cross A plus A dot del cross B. So this is the identity for del dot A cross B. Then you will see a del cross phi A. Del cross phi A, again del will operate on phi, del will operate on A. So del operating on phi cross phi A plus del operating on A cross phi A. Del operating on phi is a scalar. So we'll take grad phi cross A. The first term will give grad phi cross A, because phi is a scalar. Del will operate on scalar only as a grad. So grad phi cross A plus phi into grad A. Well, so phi into curl A. So we will get grad phi cross A plus curl A into phi. So now this is a vector. On the left hand side we have got a vector because we have a cross product that gives us a vector. Right hand side you can see both the terms are vector. First term is a vector cross product that gives us a vector. Second term is a vector cross product multiplied by a scalar that also gives us a vector. So curl of phi A is equal to grad of phi cross A plus phi curl of A. So this is the next identity that we consider. Finally, we'll consider del cross E cross H. Now, a del cross E cross H, in this case, E, hello, hello, am I audible? Hello, am I audible? Tekla, hello, hello, yes, okay. So we are taking two vectors E and H, taking their cross product, and we are taking the cross product of those two vectors with del. So del cross E cross H, what is the identity that we are trying to find out? Del cross E cross H, del will operate on E, then del will operate on H. So del operating on E cross H plus del operating on H cross E cross H. Now we'll take term by term. Now we are seeing two vector products, two vector triple products. Each vector triple product will evaluate. So we'll take term by term. You remember the back cab rule that is written in red: A cross B cross C you know that is B of A dot C minus C into A dot B. So first, let us take the first term. Del cross E cross H is equal to del E cross E cross H plus del H cross E cross H. Let us take the first term. On the right hand side, the first term is del E cross E cross H, del E cross E cross H. Following this rule, backyard rule, your A is del E, B is E, C is H. We'll use that. So B is outside, so E is outside. Then H dot del. Why H dot del? Why not del dot H? Because del is not operating on H. Del is operating on E. Therefore, H dot del E will come to the right hand side ultimately. Then minus H into del dot E because is operating on E. Therefore, we are taking del dot E. Now, in the first term, del must operate on E. E is on the left hand side, we have put it. So that will be correct. So the correction is H dot del into E. So H dot del E minus H into del dot E. So this is the first term, del E cross E cross H. Now we'll find out del H cross E cross H. Del H cross E cross H will be equal to E. E will be taken out. E is the uh, B. E is equivalent to B. So take out E, B. Then A is del H, then dot H. Del is operating on H. Therefore, I'll drop H, del dot H. E del dot H minus H del dot uh, uh, this will be minus H uh, E dot del. So minus H E dot del that is equal to minus E dot del H. So finally we'll get this one E del dot H minus E dot del H. Now we add these two together. If we add them together, del cross E cross H is equal to H dot del E minus H del dot E plus E del dot H minus E dot del H. So this is the expression for del cross E cross H. And then we'll come to the next one. Next identity is del cross phi. Now you know A cross A is equal to 0. So del cross del is equal to 0. Since del is operating on del, so del cross del will be equal to 0. So del cross phi is equal to 0. Next will be del dot del phi. Now A dot A is equal to A square. Therefore, del dot del is del square. So del dot del phi is equal to del square phi. So with this, we come to an end of the part 1. We'll take 5 minutes break. Now, since we are delayed, we'll take 2 minutes break. After that, we'll come back and start with the part 2, rest of the vector identities in vector calculus, which are important for you. Slide. अच्छा ତାକୁ ପଚାରିଲେ କହିବ କ୍ଲାସଟା ହଉଛି କି ନାହିଁ କ୍ଲାସରେ ଦେଖାଯାଉଛି ତ ପିଲାଙ୍କୁ ରାଜୀବ ଯୋଉ କରିଛି ସେଇଟା ହଉଛି କି ନାହିଁ